Very good morning to all of you. Today I want to start experiment 18. This experiment number 18 title is Determination of Sulfate by Nephelometer methods of the given samples. Based on this title of experiment and based on these subjects, so there are 4 course outcomes are prepared. First outcome is acquire capability to conduct experiments and estimate the concentration of different parameters. Then the second course outcome is compare the result with standards and discuss based on the purpose of analysis. Third course outcome is determine type of treatment, degree of treatment for water and wastewater. And next course outcome is identify the parameter to be analyzed for the student project work in environmental stream. So these are the 4 course outcomes are arrived in this title of experiment and in this subject. The subject title is Environmental Engineering Laboratory and the subject code is 18CVL67. This comes in 6th semester of Civil Engineering Department. These are the apparatus and equipments are used regularly to execute environmental engineering experiments. Okay, so that's why all of you remember these apparatus and equipments. Okay, next I want to explain about basic concept about sulfate or background of sulfate or introduction of about sulfate. Sulfate is widely distributed in nature and may be present in natural waters in concentrations ranging from a few to several thousands milligrams per liter. Many drainage wastes may contribute large amounts of sulfates through pyrite oxidation. Sodium and magnesium sulfate exert a cathartic actions. Okay, sodium and magnesium sulfate exert a cathartic action. Now let us see principle of this experiment. Sulfate ions are precipitate as barium sulfate in acidic medium with barium chloride. The absorption of light by this precipitate suspension is measured by spectrophotometer at 420 nanometer or scattering of light of nephelometer. So this is the principles of this experiment. Next, which are the apparatus are required to execute this experiment? Magnetic stirrer is required, nephelometer is required, stopwatch is required, Nestler tube of capacity 100 ml are required, beakers and weighing balance etc. are required to execute this experiment. Now, which are the reagents are required to execute these experiments? Let us see how reagents are prepared. So first, conditioning reagent is required. So to obtain this conditioning reagent, this step is given. Mix 50 ml glycerol with a solution containing 30 ml concentrated HCl, 300 ml double distilled water, 100 ml 95% ethyl or isopropyl alcohol and 75 grams sodium chloride. So these chemicals you prepared according to these steps. So we are getting conditioning reagent. So then how to prepare barium chlorides? Barium chloride is required. So these are the crystals. 20 to 30 mesh is required. Next, standard sulfate solution is required. So how to prepare standard sulfate solution? Dissolve 147.9 mg anhydrous sodium sulfate and dilute to 1000 ml double distilled water. So now it's become 1 ml equal to 100 milligram sulfates. So this is the how to prepare standard sulfate solution procedure. So after preparation of these three types of reagents, so next, what is the procedure to conduct this experiment? So step number 1, prepare standards containing 20, 40, 60, 80, 100 and 120 milligram of sulfate. So you take 6 Nestle tubes and prepare these range of magnesium sulfates containing in 6 Nestle tubes. Take distilled water in the test tube, add 5 ml conditioning reagents, add few grains of barium chloride, mix well and adjust the set zero control to get zero displayed on the readouts. So I am explaining by using nephelometer unit how to do the calibrations. Okay. So this here in second step, take double distilled water in the test tube, add 5 ml conditioning reagent, add few grains of barium chloride, mix well and adjust the set zero control to get zero displayed on the readouts. The next step, replace the double distilled water filled test tube with reference standard of highest known concentrations, that is 120 milligram per liter. Then add 5 ml conditioning reagent, add few grains of barium chloride, mix well and adjust set 1000 control to get 1000 displayed on the readout. So this is the third step, is also most important. So here we are doing the calibration of that instruments. And the next step, repeat step 3 for all the standards, that is 40, 60, 80, 100 and find the respective turbidity values. So we are getting turbidity value by nephelometer instruments. So then after knowing the 6 standard solutions with 6 turbidity value, now plot a standard graph with concentrations, that is milligram per liter on x-axis, that is concentration on x-axis, and turbidity in NTU on y-axis. Okay, plots means now you take natural graph sheets and plot the graph. Concentration on x-axis and turbidity on y-axis. Now take suitable volume of sample in a volumetric flask and dilute to 100 ml. Take suitable volume of sample in a volumetric flask and dilute to 100 ml. Add 5 ml conditioning reagents accurately, mix well. Keep the flask constantly stirred with the help of stirrer. Add barium chloride crystals while stirring. Measure the turbidity developed after every 30 seconds on the nephelometers. So then find the sulfate concentration of the sample with the help of standard graph. Okay. Now see how to rate the observations. Okay. So this is the tables to see the observations. Okay. Column number 1 is serial number, column number 2 is sample, column 3rd we are locating ml of standard sulfate solution added, and 4th column is milligram of sulfate added, and 5th column is concentration in milligram per liter, and last column is we are getting the results in NTU. So here see in serial number column 1, 2, 3, 4, 5, 6, 7, 8. So here standard 1, standard 2, 3, 4, 5, 6. So these 6 standards are you write here, and we are adding here in terms of ml, 2 ml, 4 ml, 6 ml, 8 ml, 10 ml, 12 ml on each standard solutions in each test tube. So then we are taking the reading with respect to NTO unit by nephelometer. So then we are taking the reading sample 1 in NTO, sample 2 in N2, and we are referring the plot. So then we are getting the sulfate by using standard graph. Then we are writing the results. The sulfate content in the given sample 1 is, from the graph we are writing in milligram per liter. The sulfate content in the given sample 2 is, we are getting the readings in milligram per liter with respect to referring the standard graph. So then now you write the conclusion based on the obtained results value. So these are the references are referred. First one is IS codes of 3025 series. The second is standard method of examination of water and wastewater made by Alpha 20th edition. Next is third textbook is referred to cover this experiment and these subjects in detail study. Okay, thank you one and all. Next class or next experiment I will be continue in